All right, so for the first one, it's already factored, right? So we can split and solve it. So if I set the right side equal to 0, I get tan of x minus 1 equals 0. I get tan of x equals 1. And because we're on the interval of 0 to 2 pi, I use my full unit circle. So tan is 1 in 2 places on my full unit circle, right? Pi over 4 and 5 pi over 4. Good on that part. Yeah, okay, then it's the tan of 3x, and this is one of your multiple angle ones. So tan of 3x, we're going to add the interval on and then correct it based on that 3x. So first I'm going to find where the tangent of x is 0, and that happens, think about from the initial one, we would just use the top. So it would be at 3x would equal pi, or sorry, 0, because tangent is 0 at at 0 and pi. But we just do 0 plus n pi, or 3x equals 0 plus n pi. If you included pi in there, it's not that it's wrong, it's just a duplicate answer because 0 plus pi is pi, so it's already accounted for. Then we have to divide by 3 for both the initial angle and the interval, which means x equals 0 plus n pi over 3. Now, because it fixes the interval, if it didn't fix the interval, that would have been my answer. God bless you. But because it fixes the interval, I actually have to physically find the angles between 0 and 2 pi that are on that interval. So 0 is definitely one of them. That would be part of my answers. And then I would do 0 plus, I replace n with 1. So 0 plus pi over 3, and that's pi over 3. N pi over 3 is between 0 and 2 pi. Then I'd add pi over 3 again. And I'd get 2 pi over 3. And that one is also between 0 and 2 pi. And then I'd add pi over 3 again. And I'd get 3 pi over 3, which is pi. And that one's also on my interval of 0 to 2 pi. I'm going to have to do it again. So pi, or 3 pi over 3 plus pi over 3. There's a pattern here, 4 pi over 3. Add it again, 5 pi over 3. If I add it again, I get 6 pi over 3, and 6 pi over 3 is 2 pi, and 2 pi has a parentheses on it here, so I don't include it. So all of these angles plus these two are the answers for this. Joey?
You only do like when you add pi over 3 when it's in the interval 0 to 2 pi.
Correct. If it doesn't give you the interval and it's a multiple angle one, I would have left it like this. I even could have left it as n pi over 3, just by itself.
Miss Chris Weiser?
Yeah.
You know there's 2 places where tangent is 0?
Yeah.
Could you have used the other?
Well, you don't need to because if you have 0 and you add pi to it, it's already doing pi. So when you're finding it with like where you're adding on the interval and you use tangent just the top, you use 0 to pi, but you don't include pi because 0 plus pi would include pi.
Okay.
So I don't think I would mark it wrong if you put them both. It's not that it's wrong. It's just that it's a redundant answer. Like it's a repeated answer.
Okay.
Because 0 plus pi, or 0 plus n pi is pi plus n pi. Those are the same things. If it's open-ended, it doesn't matter.
Okay.
If it's short answer, if it's multiple choice, you won't see both there.
Okay.
You would just see 0. Yeah. Or actually, you would just see n pi because you would do 0 plus n pi. All right, 2 has a secant squared and a secant, so I'm going to get everything to one side. I'm going to do secant, not like that. I'm going to do secant squared x minus secant x minus 2 equals 0. And then I'm going to factor. You can plug in your a. This would be a squared minus a minus 2, or you could factor as is. Instead of it just being x, it would be secant x. And you're looking for the factors of negative 2 that sum to negative 1. So then this would be minus 2 and positive 1, and then you're going to split and solve. So I get secant of x equals 2, and secant of x equals negative 1. And secants are not on our unit circle, but the reciprocal function would be what? Cosine. So I flip it. Cosine would equal 1 over 2, and cosine would equal the reciprocal of negative 1, which is still negative 1. Then I go to my unit circle, and I find everywhere cosine is 1/2. Where's cosine 1/2? pi over 3.
And
5 pi, nope. Yes, 5 pi over 3, sorry. I was thinking sine. 5 pi over 3. And where is it negative 1? Pi. Those are hard to read. Questions on that one? Okay, then 3. 3's got 2 different trig functions, right? And this time they're both squared. So you actually have a choice here. You could replace secant with 1 plus tangent squared, or tangent squared plus 1. Or you could replace tangent with secant squared minus 1. So you can choose there. I would say they're both probably about the same. The only reason I would lean towards tangent is because then you don't have to flip it at the end. That's the only reason. So if I am going to change secant to be something in terms of tangent, it's tan squared plus 1 equals secant squared. So in place of secant, I'm going to put tan squared x plus 1. Then I'm going to distribute the 2 to tan squared x plus 2 plus tan squared x minus 3. Combine your like terms, and I get 3 tan squared x minus 1 equals 0. Add the 1. 3 tan squared x equals 1. Divide by 3. Tan squared x equals 1/3. Then what? Square root both sides, putting that plus and minus in the front, and I get tan of x equals plus and minus the square root of 1, which is 1, over the square root of 3. And 1 over root 3 is not on my unit circle, right? Because it's been rationalized. So I'm looking for all the plus and minus root 3's over 3's, which is? Good. Every over 6. 5 pi over 6, 7 pi over 6, 5 pi over 6, 7 pi over 6. And 11 pi over 6. Raise your hand if you got all 3 of them right. Okay, how about 2 out of the 3? All right, good. Questions? That's not good.
Wait, Miss Responsive.
Yeah. All right, so 5-4 is the last section that's on your test. We are going to go one more after the test before your midterm when we do a quiz on 5-5. But this is the last one that's covered on your test. So test is going to be 5-1 and 2, which was the verifying trig identities. 5-3 that we just finished all the different kinds of solving equations. And then 5-4, which is called sum and difference formulas. So these formulas are super important, okay? These will not be given to you. There is a pattern to them, and we're going to keep repeating the pattern between now and next Tuesday, so hopefully it sinks in, okay? But you need to know these. So this is used for a couple of things. One is, let's say it asks you for the sine of, let's 75 degrees. I think that's on today's notes, right? And I only gave you a unit circle. Could you find the sine of 75 degrees on your unit circle? Is 75 an angle on your unit circle? It is not. But if I could break 75 down into a sum or difference, like 30 and 45, now I get to use this formula to find that trig function. So that's the idea behind sum and difference. So the pattern for sine goes sine, cosine, cosine, sine. And I'll say it again. We'll say it like 17 times between now and Tuesday. But if you can remember the pattern, it's going to be helpful. So sine is sine, cosine, cosine, sine. And the positive negative sign matches the original one. So if it was an angle, and these could be u plus v, these could be theta plus x. They're all just different kinds of angles. If I took two angles and I add them together, then the sine of the first one times the cosine of the second one plus cosine of the first one, sine of the second one would give you that value. For cosine, the pattern is cosine, cosine, sine, sine. So, and the sign, positive or negative, is the opposite. So cosine is cosine, cosine, sine, sine. We switch the sign. And then the tangent is the sum or the sign that matches in the numerator. So we add them in the numerator. And then 1 minus the product of them in the denominator. If it's a minus, we put a minus between them. So the first minus the second over 1 plus the product. So notice these signs are the opposite. The top one matches, the bottom one is the opposite.
Do you have to memorize
Yes. So if you memorize one of each, you should be able to get to the other ones, but we're going to use them so many times between the next 3 days of school.
Okay.
All right. This sign should be plus. It's the opposite. So first example already lays it out for you. It says find the exact value of each expression, and it gives you the two angles that it's broken down into. So A says the cosine of 120 plus 45. So my pattern for cosine is, say it.
Sine, cosine, cosine,
Mm-hmm.
sine.
For cosine, it's cosine, cosine, sine, sine. And do I match the sign or do they do the opposite? Opposite. So I would do cosine of the first angle, 120. Cosine of the second angle, 45. I change the sign for cosine. So it's minus sine of the first one, sine of the second one.
Can we use that calculator?
No, but you'll have your unit circle. Is 120 on your unit circle? I'm going to find 120 and 45 on my unit circle because I'm going to use both those angles. Hopefully we know 45, but 120 is here and 45 is here. So the cosine at 120 is what? Negative 1/2. The cosine at 45? Root 2 over 2. Minus the sine at 120? Root 3 over 2. The cosine, or sine at 45? Root 2 over 2. With me so far? Yeah? Now we're going to just multiply the pairings out. So negative 1/2 times root 2 over 2 would be negative root 2 over 4 minus root 3 times root 2, which is root 6 over 4. And then I can combine those together. I get negative root 2 minus root 6 all over 4. Good so far. Now, as an open-ended answer, that's totally fine. Sometimes you will see them factor out, like take out the 1/4, and it would be negative root 2 minus root 6. That's the same thing. Sometimes it takes out the half, and you get negative root 2 over minus root 6 over 2. Those are all the same thing. They're just rewritten in different formats. This question right now on your test is open-ended, so the first answer would have been fine. Yeah.
So there will be multiple choice on the test?
I'm not 100% sure yet. I was trying, but I think partial credit is going, just because it's easier for me to grade, but partial credit is going to be more beneficial than multiple choice. So I think I'm leaning towards, there has to be some open-ended because your verifying have to be open-ended, but I'm leaning towards not.
Does SAT ever give units?
It's probably, but that. All right. B, sine of 7 pi over 3 minus pi over 3. So what's my pattern for sine? Sine, cosine, cosine, sine. Say it. Sine, cosine, cosine, sine. And for sine, do you match the positive or negative, or do you change it?
You match it.
You match it. So this is sine of 7 pi over 3 times cosine of pi over 3 minus cosine of 7 pi over 3 times sine of pi over 3. Is 7 pi over 3 on your unit circle? No. What is 7 over 3 equivalent to? 2 and 1/3. So 2 would be all the way back at the beginning. 1/3 is the first over 3, which means we're using the same angle for both of these. So we're going to do it the long way first, and then I want you to catch something. So sine at pi over 3, our pi over 3 is here. Sine at pi over 3 is, yep, square root 3 over 2. The cosine at pi over 3, 1/2, good. Cosine at 7 pi over 3, or pi over 3, root 3 over 2. Nope, sorry, 1/2. 1/2. And the sine at pi over 3, root 3 over 2. And I get root 3 over 4 minus root 3 over 4, which is 0. So sometimes they can be simplified. Like I would check from the beginning now that you know this. What is 7 pi over 3 minus pi over 3? 6 pi over 3, and 6 pi over 3 is 2 pi. And what is the sign at 2 pi? 0. Most of them will not be able to be simplified, but obviously if you can, try it out. It might be easier. We good? Questions? All right, one step further is I'm going to give you the angle, and you have to figure out the two angles that would add together to give it to you, or subtract to give it to you. I would say a strategy I would approach is if it ends in 5, you're always going to end up using a 45. So try to work with that, okay? So if I have 105, what are two angles we could add together to give you 105 that are on your unit circle? 45 and 60, okay? You could also have done 135 minus 30. So there's more than one way to do this. So now I'm going to do sine of 45 plus 60. I'm going to do cosine of 45 plus 60. And I'm going to do tangent of 45 plus 60. What's the pattern for sine? Sine, cosine, cosine, sine. So sine 45, cosine 60. Do I keep the sine or change it?
Keep it.
Keep it.
Yep.
And then cosine 45, sine 60. So 45, hopefully again, we start to know these things. 45 is root 2 over 2 and root 2 over 2. 60 is 1/2 and root 3 over 2. So the sine at 45 is root 2 over 2 and root 2. The cosine at 60 is 1/2. The cosine at 45 is root 2 over 2. And the sine at 60 is root 3 over 2. And I get root 2 over 4 plus root 6 over 4, which is root 2 plus root 6 over 4. You both said it at the same time. Go ahead. Go ahead. Yep. It doesn't matter, actually. So if I flipped it and did 60 and 45, the ending answer would be root 6 plus root 2, and it doesn't matter. Just know that if it was multiple choice and you saw root 6 plus root 2, it'd be the same as if you saw root 2 plus root 6. So like these questions are obviously going to come back on your midterm. They might be multiple choice then. So just know that those would be the same in reverse order. All right, now do cosine. So cosine pattern is cosine, cosine, sine, sine. So cosine 45, cosine 60. Change the sign or keep it? Change it. Sine 45, sine 60. We already know these coordinate points because we looked them up already for the first one. Cosine of 45 is root 2 over 2. Cosine of 60 is 1/2. Sine 45 is root 2 over 2. Sine 60 is root 3 over 2. I get root 2 over 4 minus root 6 over 4, or root 6 minus, or root 2 minus root 6 over 4. Questions on that one? Okay, now we go tangent. What's the pattern for tangent? And it's okay if you have to cheat because we haven't really done it yet. Good. So in the top, we do a sum or difference, and it's the sign that matches in the top. So it'd be tangent of 45 plus tangent of 60 over 1 minus the product. So the bottom is the opposite sign. Top is the same sign. Bottom is the opposite sign. Now we got the x, y coordinates, but we didn't add the tangents on. What's the tangent at over 4 or 45? 1. And what's the tangent at 60 degrees or or the over 3? Root 3. So I get 1 plus root 3 over 1 minus root 3. well, it'd be 1 minus 1 times root 3. And I get 1 plus root 3 over 1 minus root 3. Oh, I meant to check. All right, you don't have to rationalize it. Let's say it was a standardized test and it was multiple choice and it didn't look exactly like that. Know that the other option would be to rationalize. So I'd multiply top and bottom by 1 plus root 3, okay? I will let you keep it like that. WebAssign will let you keep it like that, so that's fine. All right, we're just going to set up B, and I might jump to tangent just so you can see something different for a second. But now I've got 285. So what two angles can I add together to get 285 or subtract to get 285? I could do 45 and 240, right? Those are two angles. Remember, you got to find angles that are on your 45 and 240, two angles that are on your unit circle, right? So 240 is on there. You could also have done 315 minus 45 and done a difference. That works too, okay? Again, there's more than one of these. So what's your pattern for sine? Sine, cosine, and you keep the sine plus cosine, sine. Do you need me to work through it or you know where to go from there? We're okay, right? All right, then cosine's pattern. Good. 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 So cosine is cosine, cosine, sine, sine, and we change the sign. And then tan 45 times tan 45 plus tan 240 over 1 minus tan 45, tan 240. Questions? You're good from there? Yes? Okay. So here's what you haven't seen yet. What happens if I get 1 plus root 3 over 3 over 1 minus 1 times root 3 over 3? This you have to simplify further. So this ends up being 1 plus root 3 over 3 over 1 minus root 3 over 3. And you need to at least condense them to 1 in each. So I would get this is 3 over 3 and 3 over 3. I'd get 3 plus root 3 over 3 over 3 minus root 3 over 3. And then you have to keep change flip it. So you can't leave your answer in a complex fraction form. If you get an over 6, which is going to result in that root 3 over 3, you got to do it through the extra work. So I'd multiply times 3 over 3 minus root 3. If I keep changing flip, these cancel, and I get 3 plus root 3 over 3 minus root 3. That can stay, but this cannot. You cannot leave a fraction within a fraction. You can keep the radical in the denominator, but you have to simplify the complex fractions. All right, here's the best part, the reverse. When you reverse it, you just have to figure out the pattern and then do what it's supposed to do. So it says, write the expression as the sine or cosine or tangent of an angle. Looking at the pattern there, you have to figure out which trig function it is. And then based on the trig function, do you follow the sign or do you flip the sign? That's the idea behind it. So if I look at A, I've got cosine, cosine, sine, sine. Which trig function pattern is that? Cosine. And with cosine, do we keep the sign or change it? Change it. So I'm going to do 25 plus 15, and I'd get cosine of 40. And for these beginning ones, you'll literally leave it like that because that's not an actual angle you can find it of. But we'll do it one more step further in a minute where it would say like that's cosine 45, and then you actually have to find cosine of 45. Tangent should be a dead giveaway. It's the only one that says tangent in it, right? So your job with tangent is to figure out, do I match the sign in the top or the bottom? Which one? The top. So this would be tangent of 2x plus x or tan of 3x. This is the part of some difference we like. What?
For the ones like that,
You can't do anything further. So then the next step, it'll say find the exact value of the expression. So you write the expression in the form in one function like we just did, and then you'll actually use the unit circle to find the value. And those look like this.
Yeah, but there's not going to be an X.
No. It has to be a unit circle angle or a coterminal, but it has to be something you can find. All right, so A, sine, cosine, cosine, sine. What pattern is that? It's sine, and which, do I follow the sign or change it? Follow it. So I'm going to do sine of 330 minus 30, and I do sine of 300 degrees. And because you'll have your unit circle already filled in because you're smart and you'll have figured it out and you'll have filled it all in, you literally just go to your unit circle, you find 300, and you find the sign of it, which is negative root 3 over 2. B, again, we know it's tangent, but do we match the sign in the top or the bottom? Top, so 25 plus 110, and I do tan of 135. And I go to my 135, and it's an over 4, so my tangent's going to be 1, but it's in the second quadrant, so it's going to be negative 1. Question on those? Yeah.
So for this whole section, we stay in degrees?
No, it could flip back and forth. That could be in radians, and you have to add 2 radians together. Yeah. All right, then you're going to see sum and difference with triangles. So this one says, suppose that the cosine of theta equals negative 3/5 for a quadrant 2 angle, and cosine of beta, notice these are different variables. They're talking about different angles, different triangles. The cosine of beta is 12 over 13 for a quadrant 1 angle. Find the exact value of each of the following. So the first thing I'm going to do is draw myself a triangle. For the first one, it's in quadrant 2, so I'm going left and up. I'm going to put theta in that corner. If it's negative 3 over 5, which one gets the negative? The x, why? Hypotenuse can never be negative. What's the missing side? 4. That's a triple, 3, 4, 5. Then I'm going to set up my other triangle, which is cosine beta, and it's in quadrant 1. So I'm going to the right and up. I'll put beta in the corner. And my cosine is 12 over 13, adjacent, over hypotenuse. And what's my missing side? What's the triple with 12 and 13?
8, 6, 7,
Oh, this is painful.
5.
5, 12, 13. People know your triples, or you're going to be doing the Pythagorean theorem and killing yourself in time. Okay, so what's the sine of theta? Make sure you go to the right, the correct triangle. Theta is the pink one. What would be the sign? Four over 5. Then sine of beta, now we're going to the blue one, would be 5 over 13. Now it says use the sum and difference formulas here. Well, it doesn't say that, but you have to know that. If it's the sine of theta plus beta, we're going to do sine of theta, cosine of beta, plus cosine of theta, sine of beta. Sine of theta is 4/5. Cosine of beta is what was given to me up here, 12/13, but you could also find it from your triangle. Plus cosine of theta was given to you, negative 3/5, times sine of beta, we just found it, 5/13. And I'd get 48 over 65 minus 15 over 65, or 33 over 65. And you'll leave it exactly like that. So these last two involve your identities. They pull back in your identities, they pull back in your solving. So it's doing the last like 5-2 and 5-3 together. This says prove the identity. Now, hopefully we know at this point that sine of pi over 2 minus x is a cofunction, and my answer is cosine. But it doesn't want you to just say that's what it is. It wants you to prove where it came from. This is a difference, right? So if I looked at just that left side and it was sine, what's the pattern I could use to expand it? What's the difference formula for sine? Sine, cosine, minus sine, or cosine sine, right? So sine of pi over 2 times cosine of x minus cosine of pi over 2 times sine of x. What is sine of pi over 2? That's the y at the top. 1. What's the cosine at pi over 2? What's the x at the top? 0. And I'd get 1 times cosine, which is cosine, and 0 times sine, which is 0. So when it says use these to verify, you can't just write cosine equals, like I can't just replace it. You actually have to expand it. Yep.
Isn't there like
It's a cofunction. Yeah, but you're proving the cofunction, so you can't use the cofunction. That's what the point, yeah. All right, this last example pulls together 5-3 and 5-4. So it says find the solutions of the equation in the interval. But if we look at this equation, there's a sum in place of a single angle. So we're going to expand that first. It would be, because it's sine, cosine, cosine, sine. So sine of x, cosine of pi, plus, because we keep the sign the same, cosine of x, sine of pi, minus sine of x, plus 1. And then cosine of x and sine of x, of pi, we can find because pi is on our unit circle at -1, 0. Sine of x will stay that way. Cosine at pi is -1. Cosine of x will stay that way. Sine at pi is 0. So this becomes negative sine of x. This becomes 0 minus sine of x plus 1. -2 sine of x plus 1. -2 sine of x equals -1, and sine of x equals +1/2. And because we're on our fixed unit interval, we're going to not need to add the 2n pi. We're going to use the full circle and find everywhere sine is 1/2, which happens at all the over 6's. So pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6.